Hey everyone, and welcome. Today, we are taking a tour inside the modern software factory. We're going to pull back the curtain and see the incredible assembly line that builds the apps and websites you use every single day.
I mean, it really does seem like magic, doesn't it? One day it's just a concept, a little spark of an idea, and the next, bam, it's a real product that millions of people are using. Well, it's not magic, but it is an absolutely fascinating, highly engineered process.
So here's the plan for our tour. We're going to follow the entire journey, right from that initial idea all the way to what the factory of the future is starting to look like. Ready? Let's jump in.
Okay, first stop is planning. Before a single line of code is even thought about, a massive amount of work goes into figuring out what to build and, just as important, how we're going to build it. This is where the whole foundation gets laid.
This master plan for any big software project is called the Software Development Lifecycle, or you'll hear people call it the SDLC. Just think of it as the official rulebook for the factory floor. It makes sure every single step is organized and focused on one thing, making a great product. Now, here's where things get really interesting. You've got two competing ways of thinking. The old school way was called waterfall. You do one thing, finish it completely, then do the next, step by step. Very rigid. But today, most teams use Agile. The whole idea is to work in small, fast cycles, building and releasing little pieces of the product. This lets them adapt and get feedback from real users constantly. It's all about being flexible, not fixed.
Okay, with a plan in place, it's time to draft the blueprints. You wouldn't build a skyscraper without them, right? Software architecture is exactly that, making these huge design decisions that are going to affect the project for years.
And this slide illustrates one of the biggest choices right up front. Do you build a monolith, which is like one giant single application where everything is connected? Or do you go with microservices, where the app is broken down into dozens or even hundreds of tiny, independent services that all work together? A monolith might be simpler to start, but microservices give you incredible flexibility to update and scale things later on. So you might be wondering, if you have all these tiny little services running around, how in the world do they talk to each other? That's where APIs come in. An API is basically a contract, a standardized way for one piece of software to ask another piece for information. They're the universal translators on the factory floor, making sure everyone speaks the same language. They are the absolute backbone of all modern software.
All right, we've moved from the planning rooms to the assembly line itself. This is where the developers, the master craftspeople in our factory, start turning all those designs and blueprints into actual working software. I absolutely love this quote from Martin Fowler because it gets right to the heart of an idea called clean code. See, it's not just about getting the software to work right now. It's about writing it in a way that's so clear and organized that other people, other humans, can easily understand it, fix it, and build on top of it for years to come. So, to write this clean code, developers often follow a set of guiding principles. One of the most famous sets is called SOLID. It's an acronym for 5 rules that help create really robust software. For example, that S stands for the single responsibility principle. All that means is that every little piece of code should have one and only one job. That makes it way easier to fix or upgrade later without breaking something else. It's what separates a quick and dirty hack from a professional product built to last.
Now, this is where the modern factory really becomes, well, modern. It used to be that getting code from a developer's machine out to the users was this slow, manual, and super risky process. And then, DevOps came along and basically built an automated superhighway.
The key thing to understand is that DevOps isn't just a box of tools. It's a completely different culture. It's about breaking down the walls between the people who build the software, the devs, and the people who run it in the real world, the ops team. The goal is simple. Work together, automate everything you possibly can, and get new features to users faster and more reliably. And the engine that drives all of this is the CI/CD pipeline. CI is for continuous integration, and CD is for continuous delivery. The moment a developer saves their new code, this automated assembly line just kicks into gear. It automatically builds the code, runs a whole bunch of tests to look for bugs, and if everything looks good, it deploys it out to users, sometimes in just a few minutes. It's amazing. Of course, this superhighway is powered by an incredible ecosystem of tools. You've got things like GitHub to manage all the different versions of the code. Jenkins acts as the automation server, kind of like the foreman of the assembly line. Docker and Kubernetes package the apps up into neat little containers to run anywhere.
It's like an army of specialized robots all working together.
And a crucial part of this whole line is quality control. But we're not talking about some person manually clicking buttons. No way. We are talking about thousands of automated tests running every single time. There are little unit tests for tiny pieces of code, integration tests to see how they work together, and even end-to-end tests that pretend to be a real user. Nothing gets out the factory doors without passing this intense inspection.
Okay, so our product is built, it's tested, and it's been shipped to users. We're done, right? Nope, not even close. In a lot of ways, the work is just beginning. Now we have to protect the product and its users and make sure it's running perfectly 24/7.
A massive piece of this is something called data loss prevention, or DLP. You can think of this as the high-tech security system for the entire factory. Its one job is to protect the most valuable thing inside, the user's data. It's a whole strategy with tools and processes to stop data breaches before they can even happen.
And DLP has to protect data absolutely everywhere. It watches over data in motion, like when it's traveling over the internet. It guards data at rest when it's just sitting in a database. And it even protects data in use, like when it's open on an employee's laptop. It's a complete 360-degree security shield.
So beyond just security, the teams need to know if the app is actually healthy. Is it running slow? Are users seeing errors? This is where monitoring comes in. It's like the mission control room for the software. Automated systems are constantly watching for bugs, checking the system's vital signs, and scanning for trouble. All that data gets fed into these cool dashboards that give engineers a real-time view of everything that's happening.
So, we've taken a pretty good look at how software gets built today, but this factory is constantly upgrading itself. The technology is always evolving. So let's end our tour with a quick peek at what's just around the corner, shaping the factory of tomorrow.
The factory is getting so much smarter. We're seeing low-code platforms that let almost anyone build an app. Generative AI is literally becoming a co-pilot for developers, helping them write and fix code. We're also seeing totally new ways to design systems and manage data to make everything more reliable and powerful. The pace of change is just breathtaking.
And that really brings us to our final and maybe most important thought. With AI helping us code and these automated pipelines doing so much of the heavy lifting, what does that mean for the human developer? Their role is clearly changing. It's shifting away from manual labor and more towards being an architect, a creative problem solver. So the question isn't if humans will still be needed, but how our creativity will be used to steer these incredible, ever smarter factories. Thanks for joining the tour today.